All right, guys, so Tuesday, April 7th, still solving exponential equations, but it's going to be a little bit different. So I'm going to show you the last case or the last scenario of the types of exponential equations you're going to have to solve. So this first example is just going to be me comparing the types that we've already done versus the one that I'm going to show you today. So the first example, 2 to the x equals 4, really simple. Remember, the goal is to have exponents with matching base. So this is 2 to the x power. The 4 would be 2 to the second power, 2 squared. Then when they have the same base, that lets you cancel them out. So then you get x equals 2. So that's the simplest example for these. Then yesterday's lesson, I showed you ones where you actually had to change both sides, because in this first example, we can't change, or in that middle example, you can't change the 125 to match the 25. So then you had to change both of them to be exponents with a 5 as a base. So 125 was 5 to the third power. Bring the x down, and 25 is 5 squared. Then you would distribute the 3 to multiply, so you would get 5 to the 3x equals 5 squared. And then now that the problem has a base matching and the parentheses are gone, now you can cancel out the 5's. You get 3x is equal to 2. And then divide both sides by 3, so you get x is equal to 2/3. So those are the first two cases that I've shown you so far. Today's lesson is going to cover the third case, because the first two, when I was writing the problems, I chose numbers that worked really well. They were able to be changed to match. The third example, you can't change these to match, because if you try to do the same thing, if you try to do 3 to the x equals 3 to the something for the 7, 3 to the first power would have been 3, so not a 7. And then if you try to do 3 to the second power, that would give you 9. So again, not 7. So that method would not work for this last example. So here's what you do whenever that's the case, whenever you can't change them to have a matching base. So the rule is, whenever you can't change them to match, what you do is you take the log of both sides. Now, you're only allowed to do this if it's only an exponential equation, like as in there's no logarithm already in it. So assuming there's no log in the problem, you can take the log of both sides. You're allowed to do that because you're doing the same to the left that you do to the right. So this is what it looks like. So you would just literally just write log in front of both sides. So log 3 to the x equals log 7. So then what you would do is, on this first one, so you have, if you look at this, you see that you have an exponent there. What do we do whenever you have a logarithm and there's an exponent? You take that exponent and you move it in front. So then we're going to take this x and we're going to move it in front of the logarithm. So then this looks like x log 3 is equal to log 7. Now that x log 3, it's implied that it's multiplication. So x times the log of 3. Then the goal is to solve for x, right? So that means that we need to get rid of this log 3. So in order to get rid of the log 3, well, the log is multiplying the x, so the opposite would be to divide. So we're going to divide both sides by log 3. So what that's going to do on the left side is it's just going to cancel it out, leaves you with just x. So that's what we were looking for. Then on the right side, you get log 7 divided by log 3. Now, this should look familiar to you from things that we've done in the past with logarithms. Now, don't divide the 7 divided by 3. That's not the first step. The first step is to do log 7 and log 3 on the calculator. So log 7 is 0.845, and then the decimal just keeps going forever, but I just write the first three numbers. So 0.845, and then log 3 is going to be 0.477. And then your last step, your final step is going to be to divide. So when you divide those two decimals, you get 1.77. So that's the answer there. So looking at this problem, 3 to the 1.77 power is what gives you the 7. So let me show you another example. That way you've seen the same thing a couple times. So I have 105 to the x. There's no logarithms here. Can't change the 105 to match the 9. So I'm going to take the log of both sides. So log 105 to the x equals log 9. And it's always the same exact steps. Take the log of both sides. Exponent moves to the front. So x times log 105 equals log 9. Then divide both sides by log 105, because again, the goal is to get the x by itself, so I got to get rid of that. So these cancel out. You get x equals log 9 over log 105. Again, do not divide just yet. You have to take the log first, get decimals. So log 9 is 0.954, and log 105 is 2.021. Then your final step is to divide those decimals, so you get 0.472. So that's how you solve these problems where you can't get the same base. Now, if that made sense to you, that's the only example for today. You can just skip to the homework. If that didn't make sense, let me do one more example for you. So this last example is going to be 200 equals to the 2 to the x power. So again, rule is when you can't get them to match, then you take the log of both sides. So log 200 equals log 2 to the x. Now this one's a little flipped from the last two that we did, but the steps don't change. So exponent goes in the front of this logarithm. Now notice that the x goes in front of the log 2, not the log 200. So it looks like this. Then again, the goal is to get the x by itself. So divide by log 2, divide by log 2. These cancel, so you get x is equal to log 200 divided by log 2. And then again, get your decimals. So 2.301 divided by 0.301. I did the logarithms ahead of time, so that's why I know these. And then when you divide those two decimals, you get your answer is 7.643. So that's another of the same type. The only difference is that one's flipped. Now, if those first three examples made sense to you, please skip this next part and just move on to the homework. If those first three examples still didn't make sense to you, I'm going to show you a different method. Now, I really don't recommend this method because it's easy to get confused with other things later on. But if those didn't make sense to you, then I'm going to show you another way. So still the same problem, 200 equals 2 to the x power. The other way of solving this one is to actually take it from exponential form to log form. So then this is in the form x equals b to the y. So we write the conversion, y equals log bx. And then, so you end up getting, what does this look like? So the y is x, log, the base is 2, and x is 200. So when you convert from exponential to log, from exponential to log, you get this. And then, I don't know if you remember from before, it's a change of base formula. So the change of base formula said log bx, you do log of x divided by log b. So using that change of base formula, then this problem would look like x equals log 200 divided by log 2. And then that should look familiar because it's the exact same thing that we got over there. So you should get the same answer of 7.643. All right, so two methods. I don't recommend that second method, but it does still work. Here's your homework, just 4 problems, pretty simple. Again, I really recommend that you do the log method first, where you take the log of both sides, but if that doesn't make sense, then obviously you can use a change of base formula. So here's your homework. Remember, it's due by 8:30 tomorrow morning, but definitely knock it out today. If you have any questions, just message me on Instagram.